Hey, guess what? It's your lucky day. We're going to talk about rational equations. Wait, it's not your lucky day? Do you know what rational means? Yeah, I know. I tried. They are fraction equations. It won't be that bad. We're going to look at equations that involve fractions. The truth is they're going to involve more complex fractions. So you're going to find out because x is in the denominator. But yeah, let's dig in a little bit to rational equations. Now, I always like to start out with, honestly, a more simple fraction equation where x is not in the denominator. Something like x over 6 plus 2/5 equals 1 over 3. Now, there's very possibly different ways that you go about solving this problem, but I want to try to I want to try to get you to solve this problem by multiplying everything by a number. Now, what number are you going to multiply by? It has to do with the denominators, doesn't it? It's a 2-digit number that, if you choose carefully, it will cancel the denominators. It will clear the denominators. So what number is in your head? Well, if you thought of the number 30, then you thought of what's called the least common denominator. And the number 30, if I multiply it into this equation, it's going to eventually clear or cancel the denominators. Now, we're going to do that in a second, but let's talk about getting the number 30, especially if you did not get it. But even if you did get it, I want you to think about how you can, one by one, think about the factors of the denominator, the factors of each denominator. What are the factors of 6? I'm talking about 3 and 2. What are the factors of 5? Well, really just 5. The number 1 is not going to make a difference, so normally we don't require or even show that. And how about the factors of 3? Well, it's already prime, so it already is itself a factor. Now, the LCD that I have over here, you see this LCD has to contain each factor. It has to have each factor represented. So I need a 3 represented in my LCD. I need a 2 represented. I need a 5 represented. Now, somebody might say, well, you're just kind of circling all the numbers and you're just putting them all beside each other. But wait, I need a 3 represented. I already have it represented right here. I don't need another one. And so if I factor each denominator, and then if I use each of those factors, if I have each of those factors represented, we will end up with the least common denominator. Now, in a moment, we're going to do that with x's, and that's when things get really fun. But let's finish this problem. Do you remember how I said we're going to multiply by 30? And do you notice that when you do that, you actually multiply it to the numerator? That's correct. Even though it's a least common denominator, I actually multiply it to the numerator. That's how multiplication works. You always multiply to the numerator of a fraction. And if you do a little bit of math here, you can see that things kind of simplify. That's exactly why you chose the number 30, because we're going to be able to cancel each of these denominators. And all of a sudden, I'm staring at 5x plus 12 equaling 10. In other words, I'm looking at a basic equation that doesn't involve any fractions. And when you solve it, you get a happy little negative 2/5. Rational equations, they require us to multiply by the LCD. Promise, if you have a rational equation, you're going to want to multiply by the LCD. What's the LCD? Well, it's got to have all the factors represented from each denominator. I like the way that that's worded. Again, it has to have all the factors represented from each denominator. Now, there's another little caveat to this whole thing. Zeros in the denominator. Yep, if we're going to get answers that are solutions for fractions, we better make sure that they do not give us a 0 in the denominator. And we'll touch on that as appropriate. Ready to try some problems? Ready to try some problems that, honestly, they're a little bit more algebraic. They have x, and, well, they have x in the denominator. So this one's 1 over x squared minus 1 over 4 equals 1 over 8 minus x. You're going to want to use this LCD method. Please don't try to do this problem a different way. This LCD method is the way. Now what we need is what we need is to think about the factors of each denominator. Now the factors of x squared would be like x and x. Okay, so I actually have an x and another x. How about the factors of 4? When we say that, we mean like the lowest prime factors. So we break it down to like its prime factors. Yeah, when you think of the number 8, it's not just 4 times 2, but again, if I break it down to its prime factors, it's 2, 2, 2. Actually also have an x that we should make part of that. So what's the LCD going to be? Well, it's going to have an x. It's going to have another x. Now, you say, wait a minute, why do I need both those x's? Well, both those x's are needed to represent x squared. So I need both. That means I need both these 2's. I need both of these 2's. Now, for the number 8, I need 3 2's. Okay, I need 3 2's. Now look, I already have 1 2. I already have one, excuse me. I already have 2 2's. 2 2's. I just need one more. I just need one more. And now I have 3 2's. I need an x. I already have an x. Take your pick. It's one of those x's. And so my LCD ends up being x squared 8, otherwise known as 8x squared. Kind of squeezing that in there. Again, the LCD is 8x squared. Now you're going to take that 8x squared, you're going to multiply that to each numerator. I'm going to write that 3 times because I don't want to change the ink but 1 time. So here's the rest of the equation. But I want you to see how I multiply to 8x squared to each numerator, and how that allows us to cancel each denominator. Now, if you do this right, you're always going to get your denominators to cancel. Now, you might still be left with some stuff in the numerator, like this minus 2 and the x squared, but it's the denominator that's going to cancel. Now, when you cancel 8x into this 8x squared, you're still going to be left with an x, right? So we don't get rid of all of it. But no more fractions, no more denominators. Now we're just kind of staring at some old equation. Or is this some old equation? Be careful. This equation, it's kind of saying 0. I want to equal 0. Yeah, I want this equation to equal 0. It might be best if I move these numbers over here, because this equation is a quadratic equation. So I move some numbers to the other side, and I actually end up with 2x squared plus x minus 8. Quadratic equation. Wait a minute, we just spent the last couple days talking about solving these things. Yeah, you got a whole tool belt. Which tool are you going to take out? How about the quadratic formula? You can't factor this problem, so quadratic formula, unless you want to complete the square, nah, I don't really want to do that. So we've got the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're not going to write the whole thing out, but it does end up coming out to be negative 1 plus or minus square root of 65 over 4. And yeah, you can't really break any of that down. You can't simplify it. It does end up to be the solutions. And none of these numbers are going to make the denominator equal 0, because the only thing that's going to make the denominator equal 0 would be a big old 0 or another big old 0. So we're good. Rational equations, LCDs. Let's try another one. Okay, now the whole idea here is that you want to think about multiplying. Don't skip this. Don't try to do something different. Think about the factors. Listen, x is already a factor, or you might say it's already factored. So is x minus 4. Okay, it's like a binomial. Now, this guy right here, I can pull an x out, and look what I get. So what's the LCD? Well, it's got to have an x, right? It's got to have an x. It's got to have an x minus 4. It's got to have an x. I already have an x. It's got to have an x minus 4. I already have an x minus 4. Notice I'm not putting more. Honestly, if I do put more, what's going to happen is I'm going to increase the degree of the equation, making it more complicated. I don't need more common denominator. I need the least common denominator. Now, when you get good at this, you might be able to see, like, into the future. You might be able to see what's going to cancel. But we're not good at it yet. Well, maybe you are. But I'm not going to skip a step. I'm going to take my time and I'm going to show the green x, x minus 4. I'm going to show each step. Again, I'm basically recopying 3 times a green x, x minus 4. And then I'm going to cancel. And as I said, maybe you kind of felt like you could see this already. That's fine if you really can do it. Okay, we can see that we're just going to be left with x plus 4 and x minus 4. Of course, the x is canceled. But here the x minus 4s are going to cancel. So I'm going to be left with just 3x. And over here, because we know that these are equivalent, they are allowed to cancel, and I'm just left with negative 16. Do you see where this problem is headed? Well, we're going to get an x squared. We're going to get a minus 16. Step back a moment and look at what you got. Yep, it's another quadratic equation. Now, it turns out that when you make this quadratic equation equal 0, you actually get rid of some of it, and conveniently, you get x squared plus 3x, or I should say you only get x squared plus 3x, which doesn't require the quadratic formula or any fancy stuff. It just requires a little factoring. But you still want to solve the problem for your zeros. In this case, they're actually the solutions to our rational equation. Or are they? Oh yeah, you got to make sure that you don't get a 0 in the denominator. Wait a minute, if I plug in x equals 0, which was one of my answers, if I plug it in right there, I'm going to get a 0 in the denominator. Now, as long as it happens once, it's done. But you also get a 0 in the denominator here. What was the other answer? Negative 3. Is it safe to plug in negative 3 here, here, and here? Yes, it's safe. So what we got to do is go back and we got to say, sorry, you don't really count. You're extraneous. You're extra. But x equals negative 3 counts. Now, if you cross off an answer, I'll assume that whatever is not crossed off is what you do want. If you circle an answer and cross off another answer, even better. Okay, but make sure that you have checked for a 0 in the denominator. Not all rational equations require least common denominators, at least require you to physically do that. You see how these two equations, these two fractions are sort of by themselves? We call this a proportion. And who doesn't like to cross multiply a proportion now and then? Well, I've never found somebody that doesn't mind doing that. What we really want to say here is you're allowed to do that because it's a single fraction on each side. a little bit of simple cross multiply, and you don't have any denominators. Somebody says, but that's the same as multiplying by x minus 2, x plus 5. You're exactly right. It's the same outcome. So it doesn't matter how you get there. We're going to still end up with a nice little, in this case, linear equation. So, of course, 3x equals negative 22, which means x equals negative 22 thirds. So, rational equations. We might be able to use a mixture of some methods. Ultimately, it's the same idea. We're trying to get rid of the denominator. Now, in today's lesson, just like all the lessons on equations, there's an exit question. If you have gotten this paper, then take it out. If you have not gotten it, then just use your own paper. Here's the exit question. You're trying to solve this equation. Now, I'm not going to tell you too much. I wouldn't have told you too much in class either, except for what is already written here, that you don't want to forget about the number 1. If you're like, what do you mean, forget about it? Well, I don't know, maybe you want to think of it as 1 over 1, but ultimately, when you multiply by the LCD, make sure you multiply to the number 1. I'm going to get rid of all that, so make sure you multiply the number 1. All right, now, the one thing that's a little strange here is normally I would give you maybe 5, 6, 7 minutes. You guys would start solving this, and there would start to be a little chatter. Well, I'm going to need to show you now what the chatter's all about. Okay, don't worry, this won't ruin anything for you. You see, the chatter is which one of these equations, which one of these resulting equations is right. Here's the catch-22. If you're getting one of these, that might be good. That might not be good. Yeah, if you multiply by the LCD correctly, you're going to get one of these equations. Notice I said correctly. If you multiply by the LCD incorrectly, you still might get one of these equations, but it won't be the right one. So, good luck. Let's get this exit ticket right, and then you have the basic book homework that goes with today's lesson.